Hello everyone, this is Sandeep here from Physics HQ. Continuing with the lecture series of solving MCQs and sums from 12th Physics textbook of Maharashtra State Board New Syllabus 2020. In this video, we will be covering the sums of Chapter 1 Rotational Dynamics. So let us start with the first sum. Somehow an ant is stuck to the rim of a bicycle wheel of diameter 1 meter. While the bicycle owner is on central stand, the wheel is set into rotation and it attains the frequency of 2 revolutions per second in 10 seconds with uniform acceleration alpha. Calculate number of revolutions completed by the ant in these 10 seconds and time taken by it for first complete revolution and last complete revolution. So for this, let us first write down whatever is given in this question. First thing that we have is diameter is 1 meter, so radius is 0.5 meter, which is half of diameter, right? Then we got frequency of revolution, which is 2 revolution per second, time 10 seconds. Then they have mentioned that the wheel is set into rotation, means the initial angular velocity is 0. So we can write omega 0 is 0 or n0 is 0. So n0 is initial frequency of revolution. Next, what we can do over here is we can find out what is alpha. Alpha is final angular velocity minus initial angular velocity divided by time. So final angular velocity is 2 pi n. Initial angular velocity is 0 divided by time is t. So we got 2 into pi into n ka value is 2 divided by time given is 10 over here. This will cancel out. What we get is alpha is equal to 2 pi by 5 radian per second square. Now to find number of revolutions completed by ant in 10 seconds, what we'll do is we'll find out the average number of revolutions completed by the ant per second. For that, we will be using the formula of kinematical equations for angular velocity. We can write average angular velocity is initial angular velocity plus final angular velocity divided by 2. Omega can be written as 2 pi n. So we will have 2 pi n average. This is equal to 2 pi n naught plus 2 pi n divided by 2. So we can take out 2 pi common on both the sides and cancel out. What we are left is average number of revolution is equal to n by 2 because n0 is already 0. So we got 2 by 2 which is equal to 1. So we have average number of revolution as 1 revolution per second. So if wheel is performing 1 revolution per second on an average, so for 10 seconds the number of revolutions that is performed is, you multiply the average revolution per second multiplied by time, so it is 1 multiplied by 10, which we get as 10 revolution. In 10 seconds the wheel has completed 10 revolution. In the next part, they have asked to find the time taken to complete first and last revolution. For this, we will be using another kinematical equation for rotational motion, which is given by theta is equal to omega naught t plus half alpha t square. We already know that omega naught is 0, so we got equation as half alpha t square. Now for the first case, to complete one revolution, what will be the value of theta? To go around the complete circle, theta completed will be how much? 2 pi. So let us put it over here. What we get is theta is equal to 1 by 2 alpha t square. So we'll put theta as 2 pi, or 2 pi is equal to 1 by 2 alpha ka value we got it as 2 pi by 5 into t square. So we'll cancel out 2 pi and 2 pi. What is left is t square is equal to 2 into 5 is 10. So we can calculate t as root t second. Now you can calculate root of 10 by using logbook. You will get this as t is equal to 3.162 second. If you have any confusion how to use the logbook, click on the eye icon on the top right corner of this video. You will find link of the video of how to use logbook for solving sums, which will be very beneficial for solving sums in physics as well as chemistry. Now let us coming back to the sum. We also need to find how much time was taken to complete the last revolution. Now when we say last revolution, we already calculated that there were 10 revolutions completed. So for the 10th revolution, how much was the time taken? Okay, so time taken for 10th revolution is what we need to find. What we will do is, we will find time taken for 9 revolutions first, and then we will subtract this with the total time to get the time taken for 10th revolution. Let us solve it and try to understand it. So for time 9 revolution, we will put we have this formula as theta is equal to alpha t square. So t is what we need to calculate. Alpha we already have as 2 pi by 5. Value of theta for 1 revolution is 2 pi. For 9 revolution it will be 9 times 2 pi. So let us put the value 9 into 2 pi. This is equal to 1 by 2, 2 pi by 5 into t square. Once again 2 pi is cancelled. T square will be this 9 into 5 2s are 10, which is 90. So we got t is equal to root of 90. Again you can see this from the log table. You will get this as 9.486 seconds. So this is the time taken to complete 9 revolution. We want time taken for the 10th revolution. So time taken for 10th revolution is the total time that we have, and we will subtract the total time with time taken for 9 revolutions. So what will be left is time taken for 10th revolution. So total time is given as 10 seconds and time taken for 9 revolution is 9.486. When you subtract this, you will get 0.504 seconds. So this is the answer. Let us go ahead to the next sum. Coefficient of static friction between a coin and a gramophone is 0.5. So we are given coefficient of static friction which is 0.5. Next, radius of the disc is 8 cm. So radius of disc is 8 cm, which can be written as 8 into 10 raised to minus 2 meter. Initially the center of the coin is 2 cm away. So the distance at which the coin is placed is 2 cm. So it can be written as 2 into 10 raised to minus 2 meter away from the center of the disc. So if this is the disc which is going around of the gramophone and this is the center, so this distance is 8 cm. Okay, and somewhere at a distance of 2 cm the coin is placed. Okay, so the coin is placed over here, and this is going around in a circular motion. At what minimum frequency will it start slipping from there? Okay, so we need to find the minimum frequency at which it will start slipping. So this is going around in a circular motion in this path. Now it is going outside, means there is this centrifugal force. Outward force is called as centrifugal force. There is two force in circular motion: centripetal, which is towards the center, and another one is centrifugal, which is away from the center or outwards from the circular path. So we need to find that frequency for which this centrifugal force will be more than the frictional force which is holding it there. There is the second part of the question: by what factor will the answer change if the coin is almost at the rim? When coin is almost at the rim means the distance is again equal to 8 cm. So we will calculate for it. First of all, we will find out the minimum frequency. So for that we will use the formula as mr omega square. This is equal to mu n. Okay, mu n is nothing but the frictional force, right? The outward force is centrifugal force, and the force which is holding it inside is the frictional force, right? And this frictional force is given as mu s n. Okay, and what is n over here? N is normal reaction and n is given by the formula mg. Okay, so we will put it over here. So we got mr omega square, which is equal to mu s, and n ki jagah pe we can write mg. M and m gets cancelled. We got omega square as mu s g by r. So omega can be written as 2 pi f. So we will have 2 ka square 4, pi ka square will be pi square into f square. This is equal to mu s, which is given as 2.5. G, if you see in the question, it is given as pi square divided by the distance at which the coin is placed is 2 into 10 raised to minus 2. So if you see pi square gets cancelled over here. So let us take everything else on the other side. What we have is f square is equal to 0.5 divided by 4 into 2. We will take this 10 raised to minus 2 above, minus 2 will become plus 2. This will be 50 by 8, which can be written as 25 by 4. Now if we take the root on both the sides, 25 ka root is 5 and 4 ka root is 2. So we got frequency as 2.5 hertz or revolution per second. So this is the frequency that we got. Now the second part of the question says, what will happen if the coin is almost at the rim? So over here we need to see the relation between this frequency and radius. So what we see is from this equation that frequency is inversely proportional to 1 by root of r. So we can write the new frequency will also be proportional to root of new radius, right? So we need the new frequency, so we will take a ratio over here, new frequency upon old frequency. This will be equal to root of, since they are inversely proportional, we'll have r above and rn below. Old radius is 2 centimeter, which is 2 into 10 raised to minus 2 meter, divided by the new radius is 8 into 10 raised to minus 2. They'll cancel out. What we have is new frequency is equal to root of 1 by 4. So this 10 raised to minus 2 and minus 2 is cancelled, and 2 4s is 8. So when you solve this, 4 ka root is 1 by 2. So what we find is the new frequency over here is half the original frequency. I hope you all understood. Let us go ahead. Path of a racing track is designed for a curvature of 72 meter. So radius over here is 72 meter. We are not recommending the vehicles to drive faster than 216 km per hour. So velocity is 216 km per hour. We will convert this into meter per second. So to convert kilometer into meter, multiplied by 1000. To convert hour into second, every hour is consisting of 60 minutes and every minute is of 60 seconds. So 60 into 60 will be 3600. When we multiply with this, whatever we will get will be in meter per second. You can remember the short form when we simplify this and divide it by this, so we will get 5 by 18. So when you multiply velocity in kilometer per hour with 5 by 18, you get answer in meter per second. So after solving this, you will get 18 ones are 2s are. So you will have 12 into 5 is 60 meter per second velocity. Next thing that they are saying is, so with what angle should the road be tilted? We need to find theta. The formula that we have is tan theta is equal to v square by rg. V over here is 60, so 60 ka square means 60 into 60. Radius they have given as 72, and G we will take it as 10. It is mentioned in the chapter at the start that we should use G ka value as 10 unless they have specified some other value. Next we can divide this. 6 1s are 6 12s are 72 and 12 5s are 60. So we got tan theta as 5. We got tan theta is 5, and we can find out theta over here. Theta can be found out as tan inverse 5. Again you need to look into logbook over here. Please refer to the logbook wala video that we have made by clicking the I button. When you look it in the table, you will find tan inverse 5 is 78.69 degree. We got the angle by which the road should be tilted. Next they have asked is, what height will its outer edge with respect to the inner edge if the track is 10 meter wide? So let us say this is the tilted road. So let us say this is the tilted road which is there. The angle is very high, actually 78.69. They have said that width of road is 10 meter. Now people make mistake and they take this as 10 meter, but this is the actual road, right? So this is 10 meter on which the vehicle is running, and we are supposed to find out this length, okay, which is nothing but the height. Now to find this, we will be using simple hypotenuse में sin theta का formula. What we use as sin theta is always opposite upon hypotenuse. I hope you all remember this. Opposite upon hypotenuse. What is the side opposite to this angle theta? This is the side with length h. And what is the hypotenuse over here? That is 10 meter. Okay, so what we are left with, h is equal to 10 sine theta, and we have already calculated what is the value of theta over here, that is 78.69 degree. You can put this again from logbook and you will find the answer comes out to be approximately at 9.8 meter. So this height is 9.8 meter. Now there is one more question which is extension of this. They are saying that if coefficient of static friction is 0.8, find the lower and upper speed limit. So for this we need to remember the formula. Minimum speed limit is given by the formula root of Rg tan theta minus mu s upon 1 plus mu s tan theta. Let us put the values over here. So we got root of R is 72, G is 10, tan theta we got it as 5, mu s is 0.8 upon 1 minus mu s is again 5 and tan theta is 0.8. So what we get is, we get root of 720. In the numerator we got 4.2. In the denominator we get 5 into 0.8 will be 5 into 0.8 will be 8 5s are 40. And a 4 plus 1 5. This 5 can be cancelled with this 720. So what we get is 144 into 4.2. Now you can multiply this, but at the end you have root of 144 as 12. But you need to look for root of 4.2 from the log table. Once you solve this, you will get 24.59 meter per second. So this is the minimum velocity. Now what about maximum velocity or upper speed limit? So remember this understanding that for theta greater than 45, there is no upper speed limit. If you want to understand this more, you can even understand it with the formula for Vmax. The formula is root of Rg tan theta plus mu s upon 1 minus mu s tan theta. So over here if you put mu s ka value as 0.8 and tan theta ka value as 5, we will get this as how much? 4, and 1 minus 4 will be a negative number, which will be minus 3. So the root of, we don't have root of negative numbers. Those are not real numbers, those are complex numbers. Okay, so that is out of our bound. So from this we should note that for theta greater than 45, we can directly say that there is no upper limit. Okay, so let us go ahead with the next sum. During a stunt, a cyclist is undertaking horizontal circles inside a cylindrical well. So let us say this is the cylindrical well, जिसको मौत का कुआं भी बोलते हैं circus में, right? And he is going around in this horizontal circle. So let us say ये height पे वो चल रहा है with a great speed, right? And the radius is given as 6.05 meter. The necessary friction of coefficient is 0.5. How much minimum speed should the stunt artist maintain? Okay, so we need to find out V minimum. What else is given is mass is 50 kg, and there is this another part of the question. We'll come to that later on. Okay, so for a particle going in this horizontal circle along the vertical wall, the formula is already there. Minimum velocity is root of Rg by mu s. Let us put the values. Root of R is 6.05, G is 10. Mu s is 0.5. Now when you adjust this points, what you get is, you get 605 by 5 actually, and when you solve this you will get minimum velocity as 121, which is 11 meter per second. So this is the minimum speed at which the cyclist should go. Next question is, if he or she increases the speed, how much will the force of friction be? See, for this we need to understand for equilibrium there is this frictional force which is acting upward, and this frictional force is equal to the weight of this cyclist which is downward. This is balanced when it is going in a horizontal circle, so therefore this frictional force is always equal to this mg until and unless it comes down below this minimum speed. So this will always be equal to m is 50 and G is 10, which is 500 Newton. So it doesn't matter if he or she increases the speed. Only if the speed goes below V minimum, there is a problem. Okay, so let us go ahead with the next one. A pendulum consisting of massless string of length 20 cm and a tiny bob of mass 100 gram is set up as a conical pendulum. Its bob now performs 75 rpm. Calculate kinetic energy and increase in the gravitational potential energy of the bob. So initially, let us say this is the bob which is now performing circular motion in the form of conical pendulum. The length of this bob is given as 20 cm and the weight is given as 100 gram. Now it is going around in the form of this conical pendulum. So it is forming a cone over here. Let us say this is the height, this is the radius, and this is the length. Okay. First of all, it is performing how many revolutions? So it is 75 revolution per minute. For solving, we will convert this into seconds. So we will divide this by 60 to get revolutions per second. So what we get is 5 by 4 revolution per second. You can also write it as 1.25. G ka value is given as 10 meter per second. Length we got as 20 centimeter, which can be converted into meter, and it will be 0.2 meter. Mass is given as 100 gram, which can be written as 0.1 kg. Now time period is inverse of frequency of revolution. Okay, and frequency of revolution we got as 5 by 4, so time will be equal to 4 by 5 second. Why we are using this? Because time period ka formula is given as t is equal to 2 pi root of L cos theta by G. So over here we can write L cos theta is equal to, so when we take square and adjust this, what we'll get is we will get t square upon 2 pi ka square is 4 pi square into G. Let us put the values. T is 4 by 5 ka square into G is 10 divided by 4 into pi square. For simplicity, what we can do is we will take pi square as 10. So this pi square and this 10 is cancelled. We got 16 upon 25 into 4, which is 16 upon 100, which is 0.16. So we got L cos theta as 0.16. Now from this triangle over here, where this angle is theta and we have h over here, we can write h is equal to L cos theta. Again from same formula, cos theta is equal to adjacent upon hypotenuse. So for this theta, adjacent side is this side h, divided by hypotenuse is L, so we got h is equal to L cos theta. So what we'll do is we'll find out h over here is h is equal to L cos theta, which we already got as 0.16. Now what we can do is we can rearrange this. If we take L down, what is left is h by L, which is equal to cos theta, and h is 0.16, L is 0.2, so we got cos theta as 0.8 over here. So we got the angle cos theta over here. From this we can calculate theta. Theta is cos inverse 0.8. Once again we need to look into the logbook. We get something around 36.87 degree. Now to calculate kinetic energy, we have the formula half mv square. So we will find velocity first. We have this formula as v is equal to root of rg tan theta. So we can write v square is equal to rg tan theta. We have value of r, just like we found out h as L cos theta, we can write r over here as L sin theta. G ka value we already know, it is 10, so we'll keep as it is, and then we have tan theta over here. Theta ka value is 36.87. So once we put all this value, we will get L sin theta something around 0.12, G is 10, tan theta will be 0.75, and the final answer will be 75 into 12 is 90. So you'll get final answer as 0.9. So this is v square. So kinetic energy is given by half mv square, which is equal to half into mass is given as 0.1. Velocity we got it as 0.9. So this will become 0.09 by 2, which is 0.045. Kinetic energy ka unit is joules. Now the increase in potential energy. So potential energy is given by the formula mgh, right, where h is the height. Now Previously the bob was at this level. Now after going into this circular orbit, it has gained some height. How much is this part? So for that, understand this is the length L that it has, and this is the height H, this is the height H. Okay, so what is this part? This part is L minus H. So we will write this as L minus H. So that is the height it has gained, right? So let us put the values. M is 0.1, G is 10, L is 0.2, H is 0.16. So 10 into 0.1 will cancel out. 0.2 minus 0.16 will give us 0.04 joule. I hope you all understood this. That's it from this video. If you found this video useful, please share it with your friends and classmates. This is Sandeep from Physics HQ signing off.